I'm Dr. Fred DePiro, and this video is about finding node voltages. Learning objectives are to compute a node voltage using branch voltages and vice versa, and to describe the difference between node voltages and branch voltages. Prerequisite is only the ability to identify the nodes of a circuit. Okay, so why do this? Why do we need node voltages? Well, first of all, they provide another perspective on circuit voltages, and they're used directly in an analysis technique known as node voltage analysis. Furthermore, node voltages are similar to what we would measure when using a voltmeter with the reference lead, or black lead, clipped to ground. Ground is assumed to be at 0 volts. So we take our red lead and poke around in a circuit making measurements. All of those measurements are with respect to ground, and those are node voltages. So they're encountered commonly in practice. Node voltages are relative to ground, and they differ from branch voltages. So here you see typical resistor voltage across at V5, like that, with the polarity plus minus right across that one element. Now here's a node voltage, V2, node 2 right here. It is with respect to ground. Again, that's assumed to be at 0 volts, and ground serves as a reference. This is analogous to making pressure measurements that are all relative to atmosphere. To find a node voltage, we can do so using branch voltages. Start from ground, which is at 0 volts, then add branch voltages as you proceed along a path away from ground. So we start here assuming that this is at 0 volts. We have this branch voltage V5 across this first element. Therefore, the node voltage right here would be the same as V5. Moving up along the path, the node voltage up here at the top would be equal to the sum of the two branch voltages, V5 plus V4. Now, in some cases, those branch voltages might be negative or upside down, so to speak. That's fine. Same process. Start here at 0. The node voltage here, this middle node, would be -8. The node voltage at this top node would be -8 minus V1. And this can force various node voltages to be negative or below ground. And we can follow along any path from ground in order to do this. For example, branching over to the left here, the node voltage all the way to the left would be V4 plus V3. Now, this perspective on voltages also gives us some insight as to how we might simplify a series combination of batteries, for example. Suppose these 1.5 volt voltage sources were like two old school D batteries that were inside a flashlight tip to tail, like this. We can form an equivalent of those two voltage sources by describing them as a single 3-volt source, and the justification behind this is similar to the concepts we're talking about with node voltages. Okay, so our learning objectives in this video were to compute node voltages using branch voltages and vice versa, and to be able to describe the differences between node voltages and branch voltages.